Hello everyone, my name is Mr. Emil Vihandre and welcome to Physical Science.
Our topic for today is intermolecular forces. To aid us in our discussion for today, we're first going to clear some terms such as neutral, ions, and dipole. When an atom carries the same number of protons and electrons, then they are considered as neutral atoms. But if they lose one electron, which causes unequal charges, they are now called ions. By losing electron brings a positive charge. These positively charged ions are called cation. On the other hand, if they gain electrons, they gain a negative charge. They are now called anion. Remember the X-Z bond? After bonding, they gained a partial charge. Having two poles, a positive and negative, this is what we call a dipole. In reality, a dipole molecule looks like this when bonded. The intermolecular forces of attraction. For today's discussion, we are only going to discuss four types. Ion-ion interaction. For example, if sodium and chlorine undergoes an ionic bond by sodium losing electrons, both gains a charge. The bond between them is what we call the intermolecular force ion-ion interaction. Remember H2O? This is a dipole since its molecular polarity is polar, which means two poles. A dipole-dipole interaction exists when a dipole attracts another dipole. Like the molecule hydrogen chloride attaches with another hydrogen chloride, this attraction is what we call a dipole-dipole interaction. A hydrogen bond is formed between polar molecules that contain hydrogen, covalently bonded to a small, highly electronegative atom like fluorine, oxygen, or nitrogen. This is what happens during a hydrogen bond. Molecules attract one another with the use of their poles. This type of intermolecular force is unique since it requires hydrogen. Lastly, the London dispersion forces, or what we call the temporary dipoles. We have a neutral atom, neon. Neon has no charge, but if it moves close enough to another neutral neon atom, observe what happens to those charges. Their charges interact, making each a temporary dipole, with having one side negative and the other positive. This phenomenon is what we call a London dispersion force. Arranging these forces according to strength, with ion-ion the strongest, while London dispersion forces are the weakest. Where can we see the effects of the intermolecular forces of attraction? It's in the physical properties. Like boiling point, the greater the intermolecular force, the higher the boiling point. That means the higher the temperature before the fluid boils. Viscosity is the resistance to flow. Between honey and water, honey has a higher intermolecular force since it's more thick and viscous.
I hope you learned something. See you in the next video. Goodbye!